Alright guys, so let's continue the second part of the tutorial that I started earlier on, doing the same Mograph effect in 6 different applications. So here we are in Blender. From here I'm going to move to 3D Max and then we're going to finish up in Houdini. In Blender, to do any sort of motion graphics design or animation, we have to use a plugin called Animation Nodes. So you can Google it, Animation Nodes, and download it. You have to go to Edit and go to Preferences and click on Install, then locate the file where you downloaded to, install add-on, and it will be installed. And after installation, you have to activate it to be able to use it. So you have to begin to type Animation Nodes, and I can see I have activated it here. I'm going to drag off here to make a different view, not because I want 2 cubes, but that's because I want to change one of them to animation nodes. Now we need to create a new animation node tree. And after we've done that, we now have to populate this cube. The first thing we have to do is to go to Add Objects, and we want an instance. With this cube selected, I'm going to use this pick here to pick it. So we have that object in there. Now we need to set the number of instances we want, but we're going to let the grid do that job for us. So let's go to Add, and on the matrix we have Distribute. You've got a lot of options to choose, but I'm going to leave it on grid. Dragging this to it, it will just create another node called Get Length. By the way, you can get that node by going to Add and go to List, and you can see it's here, Get Length. We're going to go to Add, and this time we're going to go to Object, and we're going to look for Matrix Output. We want to put in the objects here. We grab the matrices and put them there. Now let's begin to dial up this settings here to get the required size that we want. I'm going to select both of them, highlight them. I'm going to put in like 30. Also increase the divisions. Let's do it like 25. The size of the cube is way too big, so we're going to add to matrix again. This time we're looking for offset. We're going to pipe in the matrices here, and then we're going to use that one as the output. So now we can begin to activate the scale. I'm going to select all of it. 26 will do. The next thing we have to do now is to create a follow-up for it. We're going to quickly go and add an empty object, and we want a sphere. So this is a null object. Now I'm going to select it and go to its properties and increase the size. So if I scale this all the way to like 0, if we want to do a follow-up, we can add, and under follow-ups, object controller, let me name it. Let me rename this too. So I'll rename that to controller, and I can pick it. You can use that as a follow-up for this, but there's nothing happening because the width of the follow-up is too small. So if you begin to dial it down, you can see that is only affecting the areas where we have that selected. Okay, so let me just delete it and set it back to 0.6. I'll begin to shut some of these things down just to tidy up. Go ahead and add a curve, and I'm going to go for a Bezier curve, and I'm going to hide this animation nodes. So go to the top view, so go to viewpoint and go to top. So we're going to hit tab to go to the edit mode, and we have 2 points set for us already. So I'm going to select this one, and when you press E, the E key, it means extrude, then you can move it to the area that you want to put it. I'm going to place it there. Let's zoom out a little bit, and E again. So keep on doing that till you get a shape that you want. It doesn't look cool, but we will tweak it to look cool the way we want it to be. So now we're going to tweak the curve to look better. You can select any of the handles to tweak. So for instance, if I select this one and I can hit G on the keyboard, and then that's for grabbing, to manipulate the curve to look smooth. So I'm gonna pause the video and continue to do this. Right, so I got my curve done, but I'm gonna go back to the perspective view. So now I'm gonna hit tab once more again to come out of it, and let's reactivate our clones here. With the curve selected, I want to bring it up a little bit so I can see it. So move it up. You can see it's very small, so you're gonna press S or just click here to scale it up, and I'm just gonna scale it about there. That should do. I'm also going to position it right here. So we're going to animate like that, go like that, and come out of it. But to do that, we select the controller. We want to go to Constraint, this tab here, and then we're going to choose Follow Path. And on the target, we're going to get the Bezier curve that we created. So as we've done that, you can see that it snaps to the end point of the curve. So we can use the offset to animate it. But obviously we want to start from here and animate out of it. but you can take a look at the values. It's going all the way to -7. Can we just do from 0 to 1? Yes, we can. So you have to click on fixed position, and that's gonna clamp it from 0 to 1. We still need to animate from this side to that side. Just select the curve, go back to edit mode, and select segment and switch directions. Go to the controller again, this time from 0, start from inwards, now out. We can't set keyframe on this to animate it, but I'm not going to do that just because I want to use animation nodes to do that. Go ahead and copy the instance. So I'm going to Control C, Control V. I'm going to drag it here with the controller selector. I'm going to pick that one because this is what we want to copy. For now, I'm going to make 4 copies. First of all, we need to animate it. We're going to loop through all the lists. Do that by going to SAP programs. So the function you want to create is a loop function. I'm going to name it controller loop. So if I go back to the SAP programs again, you can see that we have the new created function here that we can under invoke SAP programs. It's called controller loop. Whatever we do in this loop will not happen unless we invoke it. This is what is going to invoke this. We need a way to bring in these objects to this loop. Create a new iterator type of object we want to iterate, and that's going to be object list. When we do that, immediately it gives you an input in the invoke subprogram. Means we can fill in the objects here and we can receive them here. Go to add under animation, animate float. The value that we want to animate is on the controller and it's called offsets. To access this, go to add, and under objects we want an attribute output, and the name of the attribute is this. So we right click it and you can copy the data path, and then when you click here, Control V to paste it, plug in this object here. So we're getting an error saying that key not found. The reason is when we did the instancer, we just copied from source. So by clicking copy full object, it will copy every attribute that is. So when we do that, we get a different error saying value has a wrong type, of course, because we didn't tell it what type of value it is. So when we plug in the animate result into it, it's a float. So now it knows what value it is. We're gonna start the animation from 0 to 1. That's what we want to animate to, and want to animate it over a duration of 20 seconds. So we're going to add animation again, and we'll bring time info, and then we can plug the time in here. And what you're seeing here is the original one. We can shut it off. We can also delay the time for each of them. So we're gonna go to add, we're gonna go to animation again, and this time we're gonna go for delay. When we bring the delay here, we want to feed the time into the time, then output to time. Can plug in the index as a delay, and when we play this time, we can see we have a lagging effect going on. So what I'm going to do is to go add, I'm going to go to number, and we're going to go and choose math, and here we can plug in the index and then plug the result into the delay. So here we can use this value to multiply and create the spread. So let's go ahead and add, and the object we want to go and take object transform output. So we're going to put it here. After we've done this, we want to scale it down. So we want to choose the scale, we're going to add, then I'm going to go to number, and I want the map range. We're going to plug the index in here as the value. The iterations is the number of copies. So the maximum input is going to be the number of copies. And now when we plug this in here, you can see it's scaling it down, but it's doing it wrong way. We want it the other way around. So it's easy to fix. We just want to change the values here to 0, and then we bump this one up to 1. Now it does it the way we want it. So you can see the trailing ones are getting smaller. So now we can come and dial up the numbers and everything should work fine. So I think it's quite a bit too fast. So I'm going to do it over 40 frames. We need to spread it a little bit more. So I'm going to bring this loop down here. So we're going to go and create another subprogram loop. Let's call that one main loop, and also go back there and bring the main loop invoke. But we also want to iterate object list. So now when we've done that, we have it here. So we can pipe these objects in here. So the cubes are now here, so we can loop through them. So let's do that. We want to set the position of the cube, so we're going to object, and we're going to go transform output, and we want to connect this to it. Let's just activate translate. When we do that, you can see that it resets everything back to 0. That's because we are overriding the grid position. So we can go to add, and the objects we can get transform input, and we want to get the location and we want to add to it. So we go again, we're going to add to a vector. So we go to vector, and under vector we can get math. So now we want to bring the location. We're getting the original locations, but we can still add to it. So we need a way to bring the full of objects in here. We have to output whatever we've done here as a list. On that loop, we can generate new object lists, and once you do that, it gives you this. Position it here, and we want to send this out. Actually, I don't want to send an object list out. Delete it. I'm gonna do instead, I'm gonna go for fall off. So a list of fall offs, that's what we want to send out. So to get the fall off, I'm just gonna go there again, go under fall offs. Then we're gonna choose object controller. Then I'm gonna connect this object right here. So we have a list of fall off going out. Now if you look at the invoke here, it gives us a list of fall off going out, and we need a way to receive it in this. So we also have to provide a way to receive it. So we're gonna add a parameter, not an iterator. A parameter is a fall off list of fall off. So now we have a way to plug this in here. So we're getting the fall offs from here in here, so we can use it here. Let me just start to arrange this thing in a way that it makes sense. So I'm gonna put this all the way up. Then I'm gonna bring this whole loop down here. Let's make some more space for this one. So this is actually separate from this. Of course, we cannot use the fall off like that, and we can go to add, and under fall off you can evaluate fall off to get a float. So it's more like converting a fall off into a float. It's coming as a whole list. To go to add, and under list we can get element from the list. So if we pipe this here as the list, and now it can plug it here, but we get an error saying invalid fall off type. So we need a location fall off. Now choose that, we need to provide a location, and that's the location of the cubes are coming from here. So when we plug this value here, it's gonna create a combined vector for us. We obviously don't want it on the X, we want it on the Z. We increase the width of the fall off, so we have to come back to where we're creating the fall off and increase the width. So I am going to multiply this by a value. Let me make some more space. It's going to be a long one here. We'll add, go to number, and I'm going to go to math, and I'm going to multiply it so this way. Yes, so now why is it affecting only this? Yes, because we are selecting only that. So if we cycle through the index, you can see it goes for all of them. We cannot use this index because this index is way too many. We need only 10 indices to work on this. Go and add, go to number again, and we want a map range. Pipe in the index as a value. We use the number of iterations as the maximum. We need to get the length of the list, so we can go to add list and get length, put it right here, pipe the list into it, and use the length as the number of copies output. So now we have what we call an index that we can feed here, and you can see it shifted to the next one. Now if you scrub through, you can see that it's not doing that all the time. That is because this one, the cubes, instead of going directly to its loop, it should pass through this invoke and then come here. So let's go and create that, and I'm going to create a parameter, and that's going to be an object list, so I can name it in cubes. We want to pass it out, so we want to also generate an output of object list. That's all that we're going to do. Just place it there and then connect this to it. Let me just place it down here. So now if you come up here, we can connect this to in cubes, and it will make more sense if I lift these ones up. These are the controllers, and then we pass in this through here, and we need to get it out from here. Now when we do that, see, magic, it works perfectly. Right now they're all the same height, so we need to fade it down, even though we have the controller scale down, but the scale is not being used. The same way we fed in the fall off, we can also feed in the scale as well. So I'm going to go to the loop for the controllers, and I'm gonna create another output, and that's gonna be we need one value, so it's gonna be a float, list of a float, and that list of a float is gonna be this value out. Okay, so now when we come here, we also have to receive it. Remember, I'm gonna also add another float list here, so now we can actually connect it to it. Then again, to use them, we also want to make a copy of this get element. So we already have an index here pipe the index to it, but instead of fall off, we're gonna get the float, the list of floats. We can multiply that with this. So let me just copy this one again, paste, and let me make space, pipe this in here, and we want to multiply it with a scale. That's it, voila. So now we have it going on. So when we select the original cube, we already have a material on it. It will actually affect all of them. So for instance, if I change it to this, and you can't see until you have to switch to material mode. So let's go ahead and map the colors with the highest position on the Z of objects. So to do that, we want to go to add, and we want to go to converter, and we want to create a color ramp, and I'm connecting that to the base color, and we can set our colors here, but we need something to drive the factor. Go to input, and we want to get the geometry, and on the geometry we want to use a position Z. So we need to split this. So we want to go there once again, and on the converters, separate X, Y, Z. So that's what we want, and we'll connect the position to it. So now we can use the Z position to drive our colors. So you can see that it's doing it, but we need to now add some more points, add 2 more points. Yeah, so let's begin to change the colors here, and it's working, but it's not really shading it well. So that means we need to clamp the value that's coming here, should be clamped from 0 to 1. Add again, and then we're gonna go to convert, and this time we're looking for map range, and then we're gonna pipe it here, and when we begin to increase this value, you can see that we're clamping it down. So we can go here and change, for instance, change this color to something like that. Let's go to a full render view so we can see properly. Yeah, cool, that's better. So the black one, so now you can see we can change this color here. So that's how to achieve it in Blender. So moving on, I'm gonna go to 3D Max. Thanks for watching, and see you in the next video. Hello again, welcome to 3D Studio Max. Let's do the same effect. So by doing so, I'm gonna go here and go on the particle system, bring in a P flow. I'm gonna go to the modifier, and I'm going to go to the particle view. I do not want the positioning, I don't need it. Position icon, I'm going to delete it. I don't want speed, I'm going to delete it. I don't want the rotation, so I'm going to select the grid and overwrite it with it. See that it brings in a new icon here that contains it. So let's go to the birth and begin to play with some of the settings here. I'm going to set that to 100. The height, I'm going to make it 0 because I want a plane. Change the display type from text to display geometry, and now we can see the cubes that has been set here. You can see the shape is cube. Obviously we can change it to any type of object we want, but we're going to leave it on cube, and I'll reduce the size. I think somewhere around 2 would do. So now we have to create a fall off. Get data icon test. Data icon test, the moment we bring it here, change that to sphere. So now you can begin to see it brings us the sphere. Let's increase the diameter, and the data icon test itself is a function. So in the function is in the form of a graph. So you can edit it here by going to edit data flow. But before we go in there, let me go ahead and animate the icon first. Go to create shapes, and then we can have helix, and I'm going to hit in the middle right there and drag it, and when I let go, I'll drag again for the height, but I'm just going to leave it there because I want it flat. And the next drag is going to be the turning and the curve. Let's go to the modifiers. Let me just move it up a little bit. Now let's play with some of the settings. Let's see the radius. What does this do? Okay, yeah, increase it that way, so I can move it here. Great. Let's see, how about the turns? Oh yeah, that's cool. That's kind of cool actually. So I'm gonna bring it here. All right, so I'm gonna select it and push it here a bit. I think we're cool. Let's go here. Wait, let's go here. Yeah, we're cool. So we're gonna start from there and out. We want to select the icon and the animation. We're gonna go to constraint, and we're gonna select path constraint. When you do that, it will ask you to select the curve. So I'm gonna select the curve so we can play to see. But it's doing it, always doing it the wrong way. Yeah, we need to reverse the situation. We want to start from there. So easily swapping these keyframes. I'll bring this one there, take this one to the end. So with that done, let's go ahead to our particle flow. And so in here, let's go and make the magic happen. We have input standards and output standards. What they do is input standards basically gets the particle attributes to work with, and the output standard sets the attributes, so we get and set. So we're going to work with the output standards first. When I drag it in here, the first thing you see is the position vector to set the position of the particles. Of course, that's what we want to do, that only on the Z axis. So let's test that. Let me bring a scalar down here, and when I pipe this scalar into this by holding that red dot, I pipe it in, and I select the scalar, we can begin to see, oh, it's not working because we have to update it. And we can check auto update so we don't have to come back again. So now we can begin to see how we can affect these particles. So now let's use the fall off to do that. To do that, we need to bring in an icon. An icon is when you bring the data icon text, the icon here represents this object. We want to change that property type to inside icon. So anything that is inside, any particle that is within this icon, we want to affect it. And that is going to give us a Boolean output. So if we connect it to either this or that, it means we want to restrict all this position to the inside of the icon. We can bring in another icon, and with that selected, we want to change it to distance to icon. So the distance of the particles to this icon, that's going to give us a float value, and we can actually test it by plugging that one in here to see. So bring the function here, and we want to change the type from vector to real, then put this one here, and then we can put this value here and change the type to multiplication. Here is, I think it makes sense if I bring this one somewhere around here and take these ones up and pipe this one in here. Then we can see we can begin to decrease or increase it by changing this value right here. Lucky for us, it's kind of doing the lock for us, but it looks very ugly right now. You just have to add to the original position. We're not adding to the original position of the particles. That's why. So remember, input standard is to get attribute. So we'll bring input standard here. All we want to get is a position Z. So once we get that, we want to make a copy of this. I want to copy this and paste again. We want to add. So we want to add this to the original position Z before we multiply that one here. Nothing happens. Why? Because we didn't change it. We need to add. If you remember, I said add, we don't have to multiply. So we have to change it to add. And now when we play, we can begin to see, oh, I just set this value to way too low. So I'm going to set it up. Now I can begin to see that we have an even positioning and perfectly the way we anticipate it to be. We can set position again, copy this and paste. I obviously need this scalar. Let me paste again, and when I set this, I'll tell you what happened. Everything reset back to 0. That's because this kind of graph works in execution order. If you select the output that we are setting, if you scroll down here, you can see the execution order is 1 and this one also 1. So that means it's overriding the first one. So we need to change this one to 2. We need the position. We copy the previous one, and then we want to set it back with the value. So let me just copy and paste. We need to multiply it by a number, and then we're going to set that. So now what we begin to see here is a cool lagging effect. When we play, it fades down like that. We can control the length of this. That's why we're multiplying it with this value here. So that's to control the length. Select the particle source, and I'm going to go to modifier and bring this back again. Add a material static to it. I'm going to go to the material editor, and under anode, I'm going to choose the surface, standard surface. I'm going to bring it here. I'm going to drag off the output and point it here and say instance. So now we have a material attached to this. You can tell by changing the color to see if it does work. Yes, it does. So right click and go to maps and then anode, and under texture we want to go for ramp RGB, and we want to plug that as the base color. We can change that to custom. So when we say custom, then it's going to use this value here to map it. Oh, we're not seeing any changes because we need to change our viewport from standard to high quality. We have to turn on active shader on. Now we can see that we can use this value to select the color from all the colors that we set. Double click to add some more colors in here. Double click to add one more here and here. So let's right click again, go to maps and go to anode. We want the shading state and a vector. You can go right click maps and go to anode again, conversion RGB to float, type in the vector here, and now we can choose a float RGB So we use that to drive our shading. Turn the active shader on. We're not getting the shading right, we're getting some colors, but that's because the value that's coming in here is way too big, so we need to clamp it down. We're going to right click again. I'm going to go to our node again, math, and I need range. Pipe the input to the range, and we pipe the range output to here. So now we can begin to increase the maximum input value what we want. So when we dial this up, oh sorry, the vector that we're getting, we need to choose the position. Sorry about that, we need to set it to P, and that's sort of working now. We need to dial this down again, but that will do. Well folks, that's how to achieve it in 3D Max. So next I'm going to Houdini. Meet me there. We are in Houdini. Let's do the same effect. In Houdini there's so many ways you can achieve Mograph effects, so I'm going to obviously use one of the ways. Type in box, just double click the dive inside, put down a grid. Yep, so this is the grid. I'm going to switch things around here. It's simple, just type copy, any of them will do. Just take copy, so I'll copy the box to the grid. Let's view it. Increase the size of the grid, that should do, and also increase this to all the way to 50 by 50. Now we need to create a fall off for it. So that's where all the magic happens. So put down a sphere, and that sphere I'm gonna template it. By templating it means I still want to view this, but I want to template this and see it as well. So let's increase the size a little bit. So I'm gonna focus on the grid right now. Go into the perspective here, set the view to the top, and I'm gonna type curve, and I put it here. Select the curve. We can also template the grid so we can see it. Select this and start creating the curve. So I'm going to click here, click there, and there. Enter to complete it, and then we can change the type from polygons to nerves and type carve. So what carve is going to do is basically trim the curve. So if you activate it, you can see that we can carve it. So now what we can do is to attach this sphere to this point right here. So the one of the ways we're going to do is to use verbs. Take the sphere, then we want to do the verb on it. We can say point verb. So we also want to pipe in this curve into it. Let's view this. We want to template the curve as well. The curve needs to be animated, so let's animate the curve. So I'm going to set a keyframe there and move on to the end. Say it's about 0.99, and then alt click to set a keyframe on it. So now what we see here is a cool animation going. We need to go into the verbs and set the position of this sphere to that point. So I'm going to go in there, and we'll go in there. We have the attributes here. So the points is referring to the first input. Begin to type add, and then we're going to add some value to that point. Set that to point. Bring a constant just to make sure that it works, and let's pipe the constant in and change the value to is adding to the position. So now we need to get the second input, which is this, and then get some point from it. Go to get attribute, and when you bring that in, we can set it here to use the second input. So what is the name of the attribute we want? Obviously not color, so the name is going to be P. P represents point. Now we want to say what's the index we want to get. It is, we can just set this here and add to it. So that is done. So we can rename this to move to path, and see the sphere is moving perfectly. I'm going to go and create another verb, and this time we want to set points again, and the point we're going to set is this grid. The second input, so we're going to set that one as the second input. One will go in here to this one. So what we're going to do is to type in XYZ distance. So XYZ distance will take a position. So the position will be this. So every point we check against this second input's points. That will give us some distance value. Add. And we want to add to the original point. We also need a float to vector. So the float to vector, we can pipe the distance into the Y position and then add it to it. So we need to range this value that's coming in here. So we can get fit range, and with the fit range, we'll connect the distance as the value and connect this one to there. Immediately we begin to see we're getting something cool. It's doing the opposite way we want to do it from reverse this situation so that it pops out. But we still have some issue here. We can take care of this later on. So what we're going to go back out of here, we can add trail. If we change the settings here, we increase the length. I'm gonna do 50, reduce the size, so it just creates that for us. Now we need to fade it down. So let's create a color. I'm gonna create another verb here, control the color attribute verb this time. Say fade color. So in fade color, let's select it and go dive into that. I'm gonna look for float to vector. So I'll set that as the color. We can use this number as the red channel, but if you connect it directly, see it's a huge number, so we also need a fit range, and we want to set the maximum. Maximum is going to be the number of points, so number of points as the maximum, so we can see we have this smooth fading hit going on here. So I'm gonna go up there, so I'm gonna come into this verb here, and let's see how we can blend this with the color. So we're checking the distance here of each of the objects that is being fed in here. Can get their primitive numbers from here and get any attribute we want from them. Move this and then get some space. Get attribute. The attribute we want to get is from the same input, and the attribute index, that's the index of the attribute, will be the primitive number here. And the attribute we want to get is the color, vector to float. And when you feed in the color that's coming in here, we can get a red channel, which we've already faded. So I'm gonna add multiply. So multiply this with the red channel. Because we're reversing it here, we want it the other way around. The multiplication must be done for, so I'm gonna do it before we fit it. So I'm gonna do this, multiply before we fit it. So red channel goes in. No, actually not multiply, we're gonna add it to it. If we're doing it before we fit, then we need to add it to it. So I'm gonna add the red channel to it. Creates our log effect for us. So we want to increase the height. We can always increase this value here to be our height. I'm gonna leave it there. I'm gonna go out. I'm gonna set this to position, point position. Yeah, bring this one down. Now if we come here to increase the size, and also we can go in there, increase, but we, instead of coming here, we can promote this attributes. Promote this, so we don't have to come here and change it. So we can click there and say promote, then we can promote. So right from here, if you scroll down, we can change the values and bump it up. Go in there and type smooth to fix that. Is the strength of the smooth. Now when we come back to view this, it's already done for us. Cubes are a bit bigger, just scale them down. They're too big, just like that. To increase the trail is easy. Come here and then increase the trail to like 100, and then you got the same effect going on. So I'm gonna add another verb, and this time I'm gonna choose verb attribute. I'm gonna name it to set color. Yeah, and then I'm gonna go into it, placing down a ramp parameter, and we're going to set that to the color. We want to use the position. We also need vector to float. That's what we want, is to get the position, and we want the position Y as the input. And when we come back up, you can see that the gradient, the ramp is set in here, so we can actually set the color so easily. So we can double click to add some more. You can set this color. Obviously you could change this one to that. You can add another one here, something like that, and you can begin to move things around. Actually, I'm going to set this one to like gray. That's so we can go in there, and then before we feed it into the ramp, we can feed it into a fit range again. Sorry, fit range. We can manipulate the maximum that we can go. It's just to shift it around. So like that, we do a shifter like that. Thanks for watching, and subscribe to my channel, and I'm gonna put all these project files on my Patreon page. The link is below the description. Hit the notification bell. See you next time.